This is a video on using pneumatic cylinders to provide actuation. Here is a picture of what's called a single acting cylinder. Here's the mechanical drawing for it, and then the symbols. You can see that it's a spring return cylinder, as indicated by the spring symbol. So in the pneumatic symbol, there is only one pneumatic line going to the cylinder. So the chamber behind the piston is pressurized in order to extend the cylinder, and then when that chamber is allowed to vent, then the cylinder returns through the spring action. Here is a circuit showing control of a single acting cylinder. Quick question, what is the designation for this valve? So how many ports does it have? 1, 2, 3 ports. And how many positions? 1 position and 2 positions. So there are 3 connections to the valve, 3 ports, and there are 2 boxes, so 2 positions. And then what is the method by which this valve is switched between the 2 positions? We have a spring, so this is the normal position, and then we have a solenoid. So whenever there's electric current provided to the solenoid, then the valve moves into this position here. So here the spring is retracted. Whenever current is supplied to the solenoid, then the valve moves into the second position, and the supply air is sent to the chamber of the cylinder. So here's a question to design a pneumatic circuit using a single acting cylinder to clamp a component. And we want it to clamp whenever a push button is pressed. And the cylinder is to retract upon button release. So this is what is shown here in the previous slide. The only difference is that instead of a solenoid, we want to have a push button. So that valve in the design problem would just look like. So we got the symbols for supply and vent, and then the output. And so we have a push button instead of the solenoid, and whenever we let go of the push button, hold on, let me draw the cylinder first. So we have our single acting cylinder. When we press the push button, the cylinder is supposed to extend and clamp the piece, and when we let go of the cylinder, when we let go of the push button, the cylinder is supposed to retract. So that means we need a spring return on this valve. So when we let go of the push button, the valve returns to this position. Now, if, say, in this situation, we wanted the cylinder to slowly clamp the workpiece, then we could modify our circuit to have a flow restrictor. So that's a symbol for a flow restriction. And then if you put an arrow at 45 degrees, that means it's adjustable. So we could have an adjustable flow rate through this line, and that way we could have an adjustable speed for the cylinder. The way it's shown right now, it would have the same speed going out as coming back. Well, we'd have the same restriction going out and coming back. It might not have the same speed. And so what's typically used is this single direction flow restrictor. So here's the symbol for that. So when the fluid is going into the cylinder, the flow is restricted, but when the cylinder is vented, fluid will go this way, and it's unrestricted, so it'll flow freely to the vent. So this is a symbol for a check valve, so a one-way valve. You can see you've got this seat and a ball, and so fluid is blocked whenever it tries to go this way, but when it goes this way, it's free to go because the ball moves out of the way. Okay, so this is an alteration to the diagram where now we can have a variable speed for the extension of the cylinder. So we press the button, supply air goes through here into the cylinder through our flow restriction, our adjustable flow restriction, and out to the cylinder, and then when it's vented, flow comes back this way, unrestricted. So that was a little bit on single acting cylinders or spring return cylinders. But another type is shown here, and this is a double acting cylinder. So this is where we use pneumatic pressure or fluid pressure, both in extending and retracting the cylinder. One advantage of this type of cylinder is that there can be a bigger force for returning the cylinder. So if we need to combat gravity or parts could get stuck, if there was not enough force, then we could use a double acting cylinder. And here is a slide showing how to control a double acting cylinder. So in this slide we were using a different valve than we used in the previous one. So let's figure out the designation for this valve. The first number is the number of ports, so let's look at how many ports we have. That's how many connections are there to the valve. So we've got 1, 2, 3, 4, 5 connections. So there are 5 ports on this valve. And then how many positions? Well, that's just the number of boxes. So 2 boxes, 2 positions. So this is a 5-2 valve. And this is commonly used for switching the direction of flow. An alternative is the 4-2 valve. So this is what a 4-2 valve looks like. With a push button and a spring return, for example. So you could use this also to change the direction of flow. So in this position, flow goes into this output and from this output, and here it goes into the other output and from the other output. So anyway, using a 5-2 valve to control a double acting cylinder. Looks like this. So one advantage of a 5-2 valve is that you can have a vent placed close to the cylinder so it can retract more quickly. But anyway, we've got this 5-2 valve with a solenoid on each side. So when we supply current to this solenoid, then it'll move to this position. So current to this solenoid as shown, and it's in this position. And the valve will stay in that position if we remove current. So if there's no current to either solenoid, it'll just stay in the previous position. And then, supplying current to the other position makes the cylinder extend. Supplying current to the other solenoid, I should have said, makes the cylinder extend. And then here's another little tidbit about choosing between pneumatics and hydraulics. So you've got the issue of power and speed, or force and speed. Another example is to design the clamping fixture but use a double acting cylinder and so that cylinder is to retract upon button release. So again, this is identical to the previous slide. We would just be changing the actuation type on the valve. So instead of a solenoid valve, we would have a 5-2 valve with a spring and a push button. So here we've got I'm drawing a 5-2 valve. And so the ports are the same places in each box, if that makes sense, so that they line up whenever the valve moves, when one box moves to the other box. So anyway, here's supply, a vent, and another vent. Oops. You only draw the lines connected to it in one of the positions. I just wasn't thinking. And then, so our double acting cylinder. We've got a push button now on our valve. So in its normal state, we want the cylinder to be retracted. Would have been clearer if I'd drawn it the other way, but too late now. So the side on the right is vented, and the side on the left has pressure. And then when we press the button, the direction will be reversed, and this line will be pressurized, and this line will be vented. So that's a double acting cylinder where we have a push button to extend it, and whenever we let go of the push button, it retracts. Okay, here is another problem. Say we have a conveyor belt and we have a cylinder that's used to pick up product off the conveyor belt. So we have a human operator that's monitoring this, and whenever they press a button, then this cylinder will go down and pick up the object and pick it up. But there's also a limit switch here that's connected, that's part of a 3-2 valve, and that also has to be depressed in order for this pickup cylinder to operate. So we want the cylinder to extend when the button is pressed and when this is pressed, and the cylinder is to retract whenever either this or the button is released. So I'll introduce another new component. And that's an AND valve, or a dual pressure valve. So first of all, I'll draw the push button. So this will be a 3-2 valve with a push button. So there's the operator's push button. And then the other valve is another 3-2 valve, but it has a different actuation type. We've got that lever, limit switch. And so these two valves are connected, or their output goes to a dual pressure valve, which acts like an AND in logic. So if both these lines are pressurized, then the output of this is pressurized also. So this is pressed and this is pressed. Both these lines will be at pressure, and then the output receives pressure. Okay, and so we'll use that output in this pneumatically actuated 5-2 valve to move our cylinder. So it's pneumatically actuated with a spring return. Alright, and that's for our double acting cylinder. So whenever this line here is not pressurized, meaning when either or both of these buttons is let go of, then this 5-2 valve will be in this position. And so we want the cylinder to retract, and so this right side will be pressurized and the left side will be vented. Okay, so here's a pneumatic circuit for the problem. When we press this valve, this button, and this roller is depressed, then this line will be at high pressure, and so this pneumatically actuated valve will move into this position, and so then this line will be pressurized and this line will be vented, so the cylinder will extend. And now, why use a double acting cylinder instead of the simpler single acting cylinder for this application? Well, it could be that the force required to lift the product off of the conveyor belt necessitates the double acting cylinder. And that's the end of this video. In the next video we will look at cylinder sequencing, which is using cylinders and limit switches in order to get a